Welcome to News About Geology. Have you ever really stopped to think about how we know, like really know, what our planet is made of? All the way down to the core. Well, today, we're going to dive into that. We're tracing the amazing story of geochemistry. And trust me, it's a wild ride from old school alchemy to the super high-tech science that's decoding Earth's biggest secrets. All right, so let's just jump right in with the big one. How in the world do we read our planet's chemical story? I mean, think about it. From the super hot iron core to the oceans to the air we breathe, it's a massive, complicated puzzle. And the answer? Well, it turns out it's hidden in the elements themselves. You know the periodic table? Don't just think of it as some chart you had to memorize in school. It's more like a blueprint for our entire planet. What you're seeing here is a really cool way to look at it, showing how much of each element is in Earth's rocks. You can see the big players like oxygen and silicon, and then the super rare ones. This is literally where we start to crack the code. And this whole mission, this quest to read the planet's story, that's what geochemistry is all about. It's the science of unraveling Earth's chemical secrets. So, what does that really mean? Basically, geochemistry is the science that helps us figure out the what, the how, and the why of our planet's makeup. It looks at the whole history of the elements, where they are, and what rules they follow, from the scale of the entire Earth right down to a single atom. But, a field like geochemistry doesn't just pop into existence. To really get why it's so powerful today, we've got to go back. We need to look at its history and see how this whole way of thinking was put together. We all kind of have this idea about science, don't we? That scientific facts are just facts. They're these timeless, perfect truths. We learn them in a book, memorize them for a test, and that's the end of it. But what if that's not the whole picture? What if science isn't just a pile of facts to memorize? What if it's actually a dynamic, messy, evolving process? A story, really, full of wrong turns, happy accidents, and amazing discoveries. When you look at it that way, man, it changes everything. Because when you look at the history, you see that science is just so human. It shows you how things like who's funding the research can totally change what we find out, or how a huge mistake can accidentally lead to a massive breakthrough. And yeah, sometimes it's just about being in the right place at the right time, pure luck. And knowing all this stuff isn't just for fun trivia. It actually helps us do science better today. Okay, so let's get into that history. Let's travel back to a time when our ideas about what the Earth was made of were, well, a lot more mystical and a lot less scientific. So you had the alchemists. You could call them the earliest pioneers for sure, but their whole approach was a completely different beast from what we do now. They were working with mystical beliefs, a whole lot of trial and error, a far cry from the careful, evidence-based science that came later. And yeah, that change didn't just happen overnight, not even close. It was a slow burn over centuries. It started with just practical, hands-on knowledge back in the Bronze Age. Then things got a little more organized with mineralogy in the 1700s. And finally, you have absolute legends like Antoine Lavoisier coming along and laying down the rules for modern chemistry. That's what really set the stage for geochemistry to even be possible. All right, so fast forward to the 20th century. This is when a few truly brilliant minds took all that groundwork and hammered geochemistry into the powerful, distinct science we know today. One of those minds was Vladimir Vernadsky. I mean, this guy is one of the fathers of geochemistry. He came up with this mind-blowing idea he called the biosphere. His whole point was that life, you, me, plants, microbes, everything, isn't just along for the ride on planet Earth. Nope. He argued that life is a geological force in its own right, actively changing and shaping the planet. A total game changer. And right around the same time, you've got V.M. Goldschmidt. He did something absolutely brilliant. He looked at the periodic table and used it to create a system for classifying elements. He figured out the rules for why certain elements hang out together in certain rocks and minerals. It's like he cracked the code of planetary chemistry. And here's the kicker. The framework these guys built, we are still using it today. I mean, the work these pioneers did is a whole story on its own, and it's the foundation for everything that's happened since. Seriously, if you find this stuff as fascinating as I do, the history, the explorers, you got to check out the PGO Ricardo Valls YouTube channel. He has something like 550 videos on geology, geochemistry, you name it. It's a real treasure trove. Okay, so we've seen the past. Let's connect those dots to right now. What does geochemistry look like today? What's in the modern geochemist toolkit? Well, today's geochemists have this incredible toolbox. They use stable isotopes, like tiny little GPS trackers, to follow water and nutrients moving through an ecosystem. They use radioactive isotopes, like perfect stopwatches, to date rocks that are billions of years old. They're even looking out at meteorites and space dust with cosmochemistry to figure out how planets like ours are born. And they're carrying on Vernadsky's legacy with biogeochemistry, digging into that amazing connection between life and rocks. And listen, this isn't just for academic papers. This stuff is real. Geochemistry is right there on the front lines, helping us tackle some of the biggest problems we face as a species. You want to talk about clean water, clean energy, climate change, protecting ecosystems? You can't even start to solve those problems without understanding our planet's chemistry. It's absolutely essential. And what's so cool is that all this super advanced, cutting-edge work, it still stands on the shoulders of those basic classification systems. This chart for igneous rocks, it's a direct descendant of the kind of thinking Goldschmidt pioneered. It's the shared language that lets geologists all over the world talk to each other and understand what they're looking at. And to keep things moving even faster, the whole community is leaning into collaboration. There are these big initiatives, like One Geochemistry, pushing to make all scientific data fair. That stands for findable, accessible, interoperable, and reusable. The big idea is to make it so any scientist anywhere in the world can get their hands on the data and build on what's already been discovered. It's about teamwork on a global scale. So from its kind of mystical, hazy beginnings in alchemy all the way to its crucial role in building a sustainable future, the evolution of geochemistry is really a story about human curiosity. It's just incredible. And it makes you wonder, right? What's the next big secret our planet is holding on to, just waiting for us to figure it out? So if this got your brain buzzing and you want to keep digging, that PGO Ricardo Valls YouTube channel is a fantastic place to continue the adventure. All right, that's it for us. Thanks so much for watching News About Geology. Until next time, keep asking questions.